Here we are, live for our first 20-2. I don't know. It's not like a simulcast or anything. Okay, simple. So what we're doing is reviewing some Math 10C concepts, right? We've got a couple of days of this, and then on Friday, unless you're listening to this 3 years from now, in which case, who knows what day of the week it'll be. But simplify each of the following, and then state the number of terms, the constant term, the term with highest. The problem is when I point to it, unless I actually point to it here, you won't actually see it online. Got to remember that. All right, let's do this. So what do we have to do? We need to apply the distributive law, taking this term out front and multiplying it by this, and then we have to add 8 at the end, right? And then we collect any like terms. So what is 2x squared y times x squared? So we got a 2, right? Because there's really a 1 there. And what power of x do we have? We got x squared times x squared. X to the 4th. Because when we multiply powers with the same base, we add the exponents. Right. So we got 2, x to the 4th, and then 2x to the 4th. Well, because I want to know what comes next.
Y.
Yeah, I want to know. Oh.
The letter Y.
Gotcha.
Thanks, Alvin.
And we've got a minus what? Nope. So we're taking 2x squared y, so we got numbers, 2 times 4. 8. Okay, power of x is x squared, right? Because there's no x in here, it's not going to increase it. And the power of y. Yeah, y squared, right? So if there's no exponent written, what's the exponent? It's a 1, right? So we multiply y times y. It's a y to the 1 times y to the 1. And we multiply powers with the same base. We add the exponents. And 1 plus 1 is 2. And what do we do with the plus 8? We just throw it on the end, right? Plus 8. Do we have any like terms? They're not bad. I don't dislike them, but there's no like terms there, right? Like terms are terms that would add together, right? So if this was an x to the 4th y, and that was an x to the 4th y, we would combine them. But if we had anything, they would have actually combined inside the brackets to begin with, right? Because what's the order of operations? Bedmass, right? Or pedmass, because really they're parentheses, they're not brackets. So it's parentheses, and then exponents, and then multiplication, division, addition, subtraction, right? Full order of operations stuff. Okay, A, how many terms are there? There are 3 terms. 3. B, what is the constant term? 8. That's that joke about why is 6 afraid of 7? Or 8. I don't know. I forget. Term with the highest degree. What is the degree of this term? 5. What is the degree of this term? 4. What is the degree of this term? 0. If there's no variable, it's degree 0. So the constant term will always be of degree 0. Otherwise, we add the exponent. So 2 plus 2 is 4. And here 4 plus, what's the exponent when there's no exponent written? 1. 4 plus 1 is 5. 5 is bigger than anything. So the term with the highest degree is 2 x to the 4th y. And what is the degree of the polynomial function? Nine. Sorry, I'm answering in German now. 9. What's the degree of the polynomial function? 4. Not quite. No, you're going the wrong way. 3. No, you're going the wrong way. 5. See, you're going the wrong way for 4 and you got 3. Why 5? So the degree of the term of highest degree, in this case, which we said was degree 5, right? Because you got the 4 plus the 1 is 5. That becomes the degree of the whole function, right? So you look at all the terms. I have 3 terms. I have a term of degree 5, a term of degree 4, I have a term of degree 0. the term of highest degree is 2x to the fourth y. It is of degree 5 and defines, therefore, the degree of the polynomial function. Okay? So you look at each of the terms, you find the term of highest degree, and that is the degree of the polynomial function itself. That's just definition stuff. Okay, what do we do here? So is there any particular order you multiply, right? Is there any particular order you want to multiply in? Or what should I multiply by last? Or should I multiply the 4 into the 3x minus 1 and the 2x plus 5? Or just one of them? Both of them?
No.
No. 9. Switching to German and now back to English. So, okay, here's the order you want to multiply in. Do the brackets first, right? In other words, expand that, then do the 4 afterwards, right? So the 4 is an afterthought. We're just saying, you know what, I'm going to do all of this, I'm going to get it all down or whatever, and then I'm going to multiply everything by 4. Another way you can do this is you can multiply the 4 just into this one, or just into that one. It only goes into one, you can't. So, you know, like if you want to multiply the 4, so don't do that anyways. Do this. So you go 4, stick down a bracket, and then let's write this. 3x minus 1. So all we're going to do is we're going to throw in a pair of square brackets, and we're going to say, okay, this is the order I'm going to do this thing in, right? I'm going to multiply the two binomials together using what famous word starting with F will we use? FOIL. Remember, it's being recorded. So we're going to use FOIL. What's FOIL stand for? First, outer, inner, last, right? So when you multiply two binomials together, how many terms do you get? 4. First, outer, inner, last, right? So we've got the 4, and now I'm going to multiply. So first, what's 3x times 2x? 6x squared. What's 3x times plus 5? Positive 5. Plus 15x. Okay, so that was first, and then this is outer, right? The outside term. Now we do the inside term. So inner or inside, what's negative 1 times 2x? Negative 2x. Whoops. And, so that's inner, and then we do last, what's negative 1 times positive 5? Sorry? Minus 5. Yeah, pretty soon it'll be minus 5 outside. Probably sometime in September. Okay, what do we do next? We're supposed to be doing this. So now, do we have any like terms? You can answer yes this time. Yes, we do. What are they? The 15x and the minus 2. So we can collect like terms, right? So that equals 4 times 6x squared plus 13x minus 5. Okay. Now, if you're a pro at multiplying binomials together, you know the FOIL thing. You know the inner and the outer terms are going to collect together, right? So you can look at this and say, okay, I'm going to get 6x squared plus 15 minus 2x is plus 13x minus 5. So if you want to go straight to here, that's cool, right? I mean, but, you know, if you want to take your time, okay, so whatever you feel comfortable with, just don't get this wrong. So if you want to write out all 4 terms, just remember, I'm multiplying 2 terms by 2 terms, and 2 times 2 is 4. I'm going to get 4 terms, but there will be like terms that collect together. And then ultimately, now I multiply through by 4, giving me what? 24x squared. 4 times 13. 52, right? Number of cards in a deck. You got 4 suits with 13 ranks in each suit. So it's 52. Minus 20. Okay, so that is the answer. Right? So if you're multiplying binomials together and then there's some number in front, multiply the binomials together, then go through and multiply that number by it. That's the easiest way, right? Always get the right answer. Unless you make a mistake, then you get the wrong answer. How many terms are there? 3. Yes. B, what is the constant term? No. Yes. Okay, it's not 20, right? It's negative 20, right? Because minus 20. You could write this as plus negative 20. So the constant term is negative 20. What is the term with the highest degree? 24x what? Squared. And what is the degree of the polynomial function? 2. What do we call degree 2 polynomial functions? Quadratics. Right? That's Friday stuff. Okay. We good to go? Good to move on from here? Moving on. Factor each. Factor each of the following polynomials. Remember to factor a common factor first if possible, and then continue. I always forget to do the I don't always forget. I often forget to common factor first. So it's something that we really need to be aware of, right? Just say, is there something that goes into 4x? Like, do all of these? How many terms are there here? 3. Do they have anything in common?
Yes.
Which is what?
4y.
Well, I need to know if they, yeah, old joke. So they all have a y in common, right? So we're going to factor that out first. So we're going to go y, put down a bracket, and say, okay, so if I take the y out of 4x squared y, what do I get? Get 4x squared. If I take the y out of 8xy, what do I get? 8x. If I take the y out of y, what do I get? Okay, so when I multiply this times this, it has to go back to this, right? So y times 4x squared gives me 4x squared y. Y times negative 8x gives me minus 8xy. And y times what gives me y? 1. So I need a 1 here. So when you common factor first, you will have as many terms in your factorization as you have to begin with, right? You have to have the same number of terms. Because this line that I've written has to multiply back out, right? So you can't just say, well, we're just going to leave off the plus 1 there at the end because you won't get the plus y out of it. So however many terms, you always say, hey, there's 3 terms and there's a common factor. That means I'm inside my brackets. I have to have 3 terms. Okay, how many terms?
3.
Any common factor? No. Okay, so we cannot do a common factor first, so we need to try and factor this. I'm going to give you such easy ones, right? It's like, this is not an easy one, by the way, right? It's like, what? Okay, so factoring trinomials, So remember, when we multiply the 2 binomials together, we got 3 terms, right? We got 4 products, FOIL, F-O-I-L, first, outer, inner, last. 2 of them, the outer and the inner, collected together to give us that 1 term. So when we factor a trinomial, it's going to be the product of 2 binomials, right? So I factor by a method called guess and check, right? So here's how guess and check works. I need 2 numbers that multiply to 10. What are 2 possible numbers that multiply to 10?
2 and 5.
2 and 5 or 1 and 10, right? I'm going to say odds are it's 2 and 5. And I like 5 better. So I'm going to start with 5. So 5x times 2x is going to give me my 10x squared, right? Because the first term in the trinomial, the 10x squared, comes only from the product of the 2 first terms, right? The last term in the trinomial, minus 3, comes only from the last 2 terms, right? It's outer inner that collect. So I need a minus 3. How do you get what 2 numbers multiply to 3? 1 and 3, right? That's it, the 1 and the 3. So I say, okay, if I put a 3 here, I'm going to get a 15. All right, that's cool, because if I put a 1 there, I'm going to get a 2. And if I put a minus 3, I'll get minus 15x, right? So the numbers are 1 and 3. And if I put them down this way, then I'll get minus 15x plus 2x, and minus 15 plus 2 is minus 13, which is what I want. And I've got the 1 and the 3 giving me a minus 3, right? So that's how that works, okay? That's called guess and check. Now, I don't care how you factor, okay? So if your factoring skills aren't that hot, factoring, go to Khan Academy. You ever heard of Khan Academy?
Yes.
Yeah, there you go. You ever been to Khan Academy?
No.
No? Yeah, right. I've heard of it, but I've never gone. Go to Khan Academy and look it up. Find some videos on factoring. Like, 'cause I don't care how you factor. I just need that you be able to factor, right? And so I'm not really going to sit around and teach this, but I'll give you a hand with it. So if you want a hand with it, I have some videos out on factoring, like we're taping this, right? Taping. Where do you see a tape? When I was in high school, we taped stuff. Like it actually went onto magnetic tape. So that's why I say taping. I am recording this, and I have recorded other videos on factoring. All of my videos are up on YouTube. And my channel is, I think, SL Yanover or something. So if you do that, you're going to see that there's like 200 videos on anything from, and some of them are on factoring. Okay. So if you went to YouTube and typed in SL Yanover factoring, you're going to find some videos, likely. Okay. So you can watch those, right? Or you go to Khan Academy and watch those, right? But you need to be able to factor, so, you know, got to get your factoring skills up. There's many ways to factor. Find what works for you and use it, right? So there's decomposition. Some of you may have learned that. Use that. This is guess and check. Use that. Whatever, right? Like just find something, or just go onto YouTube and type in factoring trinomials, right? Of the 700,000 hits, you know, look for one and just start watching and just say this doesn't make any sense and watch another. You know how to use YouTube, right? Okay. So find something that works for you and use it. Guess and check, though, means that I also have to check, right? So I've guessed. I think this is it, so now I check. 10x squared minus 15 plus 2 is minus 13 minus 3. Okay? Usually what happens is you get these signs wrong, right? Which means you end up with 10x squared plus 15 minus 2 is plus 13, at which point you go, oh, right number, wrong sign. Got to reverse my sign. Right? So always check. That is the most common mistake people make. It's not finding the numbers, it's that you reverse the signs and then you never bother just checking it out and saying, oh, hang on, I've got the wrong sign. Okay. Dragging down. Simplify and evaluate. Okay. Kind of looks like the one we did before. So simplify means to make it simpler, right? In other words, multiply it out and collect any like terms together. And evaluate means, okay, now we put in those values. Okay, so simplify part. I think we already did this one, right? Like, so simplify first is to multiply it. So that's 2x to the 4th y minus 8x squared y squared plus 8. Okay? That's the same one we did, right? So, you know, if you're looking, how did you do that? Just go back to how we did that. Okay, and then evaluate means now we substitute in, wherever we see x, we write a minus 1. And wherever we see a y, we write a 3. Okay, so now we substitute in. So we simplify and multiply it out, and that's just the one we did before. So. And then we need to evaluate. So evaluate means to do what? Find a value, right? Work it out. What is negative 1 to the power of 4? We're just saying, what's negative 1 times negative 1 times negative 1 times negative 1? Okay, what's negative 1 times negative 1? No, just what's negative 1 times negative 1? Positive 1. Okay, so that's 2 of them. What's positive 1 times negative 1? Negative 1. That's 3. What's negative 1 times negative 1? Positive 1. Okay. So when you raise negative 1 to a power, it's going to flip, right? It's going to be positive for odd power, or sorry, for even powers, right? Because they'll each pair up. So I've got negative 1, and then I've got negative 1, right? Okay, we'll think about this over here. So any even power, they're going to pair up and make a positive 1, right? So really, when we're doing negative 1 to the 4th, we're doing this. And we can kind of think about it this way. Hey, let's pair these guys up and these guys. So that's going to be 1, and that's going to be 1. So it's going to multiply out to 1. Okay. So that's a negative 1 to the 4th. So we have 2 times 1 times 3 minus 8. What's negative 1 squared? What do you get when you square a negative? Positive, right? So that's a 1. What's 3 squared? 9. Yes. Trying to think of what yes in German was. Yeah. Oh. Okay. What's 2 times 1 times 3? 6. What's 8 times 9? So 6 minus 72 plus 8. What's 6 minus 72 plus 8? Negative 58. I'll write it down. I don't know if it's right or not. Somebody needs to say, hey, wait a sec, that's not right, or that's right. Or look at the answer. So is that right? Yeah. All right. She's certain it's right, so therefore it's right. Let's move on. Did you use a calculator?
Yeah.
Oh, all right. Well, then it's got to be right. Because calculators never lie, except that chapter in the book says lies by calculator told me. No, that is actually right. That's right. Okay. So use your calculator. We are never going to take your calculators away from you or not allow you to use it or next day change your calculator on this, right? Because it's not math 31. You can always use your calculator. Okay, any questions on this? Easy peasy, right? Yeah. Solve the following equations for x. So what does solving mean? What do we have to do?
X is 0.
X is 0. Yeah. X were 0, your mark would also be 0.
You gotta get X by itself on the other side of the equal sign.
Okay, so we gotta solve for x. Wow, that's a good definition. How do you solve for x? You solve for x. What we want to do is we want to find the value of x that makes that true, right? There's only one number, one value for x that makes that equation true. That's an equation, right? Equation has an equal sign, which means you can solve it. So when you see the word simplify, right, because we've done simplify. Simplify just means come up with another expression, right? Like multiply this through and then collect like terms and come up with a different expression. But you can't get a value for it, right? We can't go back to here and say, hey, x is 5. That makes no sense. Why? Because if x is 5, this is whatever this, like some number, but this isn't equal to anything. So all we can do here is we can factor it. And what we can do here is we can simplify it. But we can't solve for anything, right? Here, you can simplify, come up with, this is simpler, right? There's only 3 terms here. And we can say, hey, there's 3 terms, and the term of highest degree is 24x squared, and the constant term is negative 20 is of degree 2. So we can say stuff about it, but you can't come up with a value for x, right? The only time you can come up with a value for x is when there's an equal sign. Right? And then we can say, okay, look, x is 5. If x is 5, this is going to work. By the way, x is not 5. It's actually negative 5. But we have to solve this, right? Okay, so how do we solve and so isolate the x, get x by itself? So I kind of look at this and think order of operations and think, do that backwards. So order of operations says, if I had a value for x, what would I do with it? Well, first thing you do is multiply it by 4/5, right? And then you would add 3. So in solving, we want to do those backwards. So we don't want to add 3, we want to unadd 3, which is minus 3. We want to subtract 3 from both sides, right? So this becomes 4/5 x, and this becomes 1 minus 3. Okay, I'm going to write that. I'm going to go into more detail than is really needed, right? Because you could have just written 4/5 x is equal to negative 2. So it'd be okay to go from there to there, right? It's also okay to write the minus 3 in there. It shows you this is what I'm doing, right? Some of us need to see a bit more what's going on there, right? And when it's just sort of written out, it's like, how did you do that? Okay. So I'm subtracting 3 from both sides. I mean, really, if we wanted more detail on this, we could shove this over a bit. So you could write that, right? You could say I've got 4/5 x plus 3, and I got to get rid of the 3, so I'm going to go minus 3. Whatever I do to one, remember, it's an equation. Equation is balanced, right? These are equal, so they're balanced. If I subtract 3 from this side, then to bring it into balance, I have to subtract 3 from this side. Then they'll still be balanced. So I can do the same thing to both sides. Okay? So that's kind of, if it's me, I'm just writing this, right? I'm just going to subtract 3 from both sides, and 1 minus 3 is negative 2. Okay, now what do we do? So I do this in 2 steps, right? We could multiply by the reciprocal of 4/5. What's the reciprocal of 4/5? 5/4. So if we multiply by 5/4, what's 5/4 times 4/5? It's just 1. Right? When you multiply by the reciprocal, you're going to get 1. That's too much work, right? So what I'm going to do is, let's get rid of the 5. So what's the 5 doing? The 5, what operation is the 5 doing? Dividing. What's the opposite of dividing? So what are we going to do to both sides? Multiply by 5. When you multiply 4/5 by 5, then the 5's cancel, right? You multiply by 5, divided by 5, those cancel, right? And when you cancel stuff, you get 1s there. They don't become 0s or anything, right? 5 goes into 5 once. So this side becomes 1 times 4 over 1, which is 4. And this side becomes 5 times -2. Oh, there's still an x there, right? So let's not forget the x, because we've got to solve for something. So since we're dividing by 5, we're going to multiply both sides by 5. I wouldn't show this, right? So here's my next step. So I would do this. So I would go from here to here to here. Okay, and now to get x by itself, what do I have to do?
How would you get
Multiply both sides by 5. Okay, so this was -2, right? 1 minus 3 is -2. You've got to multiply both sides by 5. Why? To get rid of the 5 that's on the bottom there. Okay, and 4x is -10, so x is equal to -10 over 4, which simplifies to -5/2, right? So where I've drawn the arrows in, that's the work that I would show. Right? That's the sort of, it's about the least you can do. What's the least I can do for marks, right? Because I like to do the least I can do. So the least you can do for marks is where the arrows are there, right? So just show me your thinking. That's the whole point, right? We're not actually teaching you math. Nobody cares. Right? There's no jobs downtown on factoring polynomials, right? You can look through the jobs you wanted. It's like, you know, can't find anything for factoring polynomials. I suck at it, so it's a good thing, right? I mean, the jobs that aren't apply for the factoring a polynomial job. Right? What we're teaching you is some concepts, some logical thinking, and more importantly, most importantly, is communication. A friend that did engineering, right? So I said to him, so when, you know, when you're in university doing engineering, what's the most important course you took? But he's going to say math, right? Because math is the most important course. What did he say? English. I said, why English? Why English? He says, because I have to write a lot of reports. And if I cannot write a report that people can read and understand, then I'm not going to have a job. Right? I can't put out crap. It's got to be something that makes sense. It doesn't mean I don't use math in doing my reports, but I need to be able to communicate, right? And so you need to be able to communicate your solution. So if somebody else is looking, somebody says, how'd you do A? And you know, all you've done is written down, you know, you went from here to x equals -5 over 2. Then they're going to go, huh? How did that happen? That's what's important. How did that happen? That's the question. Sure. And forevermore, when somebody plays this back on
Please
YouTube.
excuse the interruption. If
Oh,
you
wait.
put the last name P to T, and you don't have books or need to change your book, please proceed to the book room.
What?
Students P to T.
Oh, P to T. That actually makes sense, right? Because there are letters between P and T. Right. Okay, so what do we do here? So before you can solve this, you need to simplify this, right? So we're going to have to multiply out that 3 times x minus 4. Okay. So in solving this type of equation, right? So here is pretty, you know, you subtract 3 from both sides, multiply by 5, divide by 4. Okay, so here we're going to go 2x plus, okay, what do we get? Can't wait. How much of this do we have to do? How much time do we have? 11:50. So Wednesday and Thursday are kind of weird this week, right? So, 24 minutes. All right, we better speed up. Spend too much time. Okay, so 2x plus 3x. So before we do anything else, let's collect like terms. Okay, so we expand the brackets, we collect like terms, and then we say, all right, What does it say? So you got to get your x's on one side. Okay? Which side? Doesn't matter. But if I subtract 8x from both sides, I'm going to get a negative 3x. And I hate negative 3x, right? I don't want a negative x. So I'm going to subtract the 5x from both sides, which will give me a 3x over here, right? So if I do that, then this 3 needs to go to the other side, right? So I'm getting my x's on the right side and my constant on my, my number, which is the constant, on the other side, which is not right, so it's left. So what do I do with this 3? You got two choices. Well, you got 4. You can add, subtract, multiply, or divide. Subtract. Okay, what's negative 12 minus 3? Negative 15. Okay, how do we get x by itself? Divide both sides by 3. Not only that, we're going to interchange sides while we're at it and get x equals negative 5. Right? Because our x should always be on the left. So technically, the in-between line reads negative 5 is equal to x. But we're not going to write that, right? We're going to say, hey, it's an equal sign. It means the left and the right side are equal. So I can swap them. Okay? So I moved the 5 over to the right-hand side because it gives me a positive x. I don't have to worry about dividing by a negative. Okay? And there we go. And it's fine. We could have had negative 3x is equal to positive 15, and then x equals negative 5. When you solve, you can also check, right? Put a negative 5 back in here. So 2 times negative 5 plus 3 times negative 5 minus 4 is equal to 8 times negative 5 plus 3. Actually, I'm going to put a question mark there because it's sort of like, I think it is, but I don't know it is, right? There's a question. Is it? So this is the check, right? So I get negative 10 plus 3 times negative 9. Is that equal to negative 40 plus 3? So is negative 37 equal to negative 37? Yeah, it is. That's a very quick check, right? So you've solved, you can also verify. Anytime you solve an equation, you can go back to the original and you can verify your solution. Okay? So if you have time on a test, I'm going to hand it in half an hour early, but I didn't look at anything to see if it's right. Take your time, verify. What else? You have somewhere to be? I mean, you're stuck here, so might as well use the time. Okay, questions? Right, so we got to do A through J. E, graph the equation y equals x squared plus 2x minus 8 by completing a table of values and thus sketching the graph. I think that should say, and then sketching the graph. Unless it says that on yours, because it's quite possible somebody picked that up and made the change. Does it say and then? Nope. Well, I haven't done this course before with these worksheets. So. Okay. So we need to substitute negative 3 in for x and then work that out. Okay. I'm just going to do it, right? And then, I'm just going to do it in my head. So what's negative 3 squared? 9. So we've got 9. What's 2 times negative 3? So that's going to be minus 6, right? So we have 9 minus 6, which is 3, minus 8 will be negative 5, right? So first line. You can use your calculator for this. Here's the thing. If you use your calculator for this, make sure you enter it like that. Do not do this. Okay? You do this, you're going to get what? What's your calculator going to give you if you do this? Negative 9. What's your calculator going to give you if you do this? Positive 9. Which one do you want to do? I want to do this because it's the negative 3 I want to be squaring. Here's what this says. This says, give me the negative of 3 squared, right? Order of operations. Do that, right? So square the 3, you get 9, and then take the negative of it. We don't want that. We want negative 3 squared, right? We want to square the quantity negative 3. So on your calculator, if you're squaring a negative, put it in brackets. Okay, negative 2 squared is, we got 4 minus 4, so that'll be negative 8. Negative 1 squared is 1. 1 minus 2 is negative 1, so it'll be negative 9. 0 gives me negative 8. By symmetry, 1, so we got 1 plus 2 is 3, minus 8 is negative 5. And we've got 4 plus 4 is 8, minus 8 is 0. Okay, so I kind of rushed through that because the clock is ticking. Not really, neither of these clocks tick. They're not mechanical. So. Is that clock right? Close. Okay, so we got to graph that. So let's put a little scale on here. Let's try and get the scale going, right? Okay, so there's a little scale there, right? And we're going to go down to -9, and we don't really have to go that high, so... yeah, that scale. So I'm going to go by -3, right? So -3, -6, -9. Okay, and so -3 gives me -5, which is going to be, let's get some different colors. So that's going to be about here. Not quite, it's going to be more about here. -2 gives me -8, that's about there. -1 gives me -9, that's about there. 0 gives me -8, that's there. 1 gives me -5, and I said that was at -5. So symmetry comes in here, and 2 gives me 0. Okay, we should join these. Draw arrows on both ends, right? It's a quadratic function. Right? We're going to be studying the heck out of it starting Friday. Verify the graph in number 5 by graphing the equation using a graphing calculator. Write down the window settings. All right, so here's my TI-84 plus. So basically, if you have a TI-84 plus, you're going to see what I'm going to see, right? Which is nice. If you have TI-83, you'll see some different stuff, but it's, you know, substantially the same. So I'm going to go to y equals. I'm going to clear out what's in there. I'm going to go x squared plus 2x minus 8. And I'm going to go zoom and 6. So zoom 6 gives me the standard window. And the standard window says your x's go from -10 to +10, and so do your y's. Okay? At which point, now, if I want it to look like this, then I need to set the window. So I can reset the window and say, well, let's go from -3 to like +2 to match that. So first of all, I look at this and I say, yeah, you know, they look pretty much, you know, the same. If I want the exact window, I can go from -3 to +2, and I can go from, well, -10 is reasonable. You know, with a scale of 1, right, just as I put a tick every 1. And y min, -10, that's good, right, because if I put -9, it's going to bottom out on the window, and I want to see just a little below. So this should go almost to the bottom of the window, but not quite. And x max, I'm going to leave it as 10, because really it's saying there's stuff up here, so let's just see what that looks like. Okay, and that's, you know, maybe a little, actually, the original looked better, right? But this should match up pretty much with that, but, you know, I go back to that. Zoom standard. I prefer this, looks better. Right, I could check values. So you go second calc and you say, all right, so look, if the value is -3, okay, I get -5, that's good. If I really want to check my values, I can go second function graph, go into the table, and say, all right, we're at -3. Damn it. All right, just stop. There we go. Okay. So -3 gives me -5, -2 gives me -8, -1 gives me -9, 0 gives me, yeah. So actually, you could have just typed this in your graphing calculator and copied the table into the table. Right? Save some work. Who's going to know? Verify the graph by write down the appropriate window setting. This window setting does not match that window setting. Really, we should be using the one that's there, but I think it looked better just in the standard window, so that's what I'm writing down. So what this says is an x window setting is x min, -10, x max is 10, and x scale is 1. So x min, x max, and x scale. And then the same thing for the y's. Okay, questions about this? Graph calculator stuff, right? Write the domain and range for each of the following. What is domain? The set of all x's. The first coordinate, right? It's the independent variable. So the set of all, so I've got a 1, a 2, a -3, and a 2. So here's what I'm going to do. Domain. So we use a set of brace brackets, right? Those kind of curly brackets. And I'm going to start at the bottom. So I start at -3. And then what's next? I've got a 1, and I've got a 2, and then I've got another 2. When I write down the domain, I never repeat an element, right? There's 2 is in the domain. It doesn't have to be in there twice. And if it is in there twice, it's actually wrong. So my domain is -3, 1, 2. It's nice. I could have written 1, 2, -3, right? But if I did that, if we agree, hey, let's go in order from smallest to biggest, then we'll all be looking at the same answer, right? We're all looking at -3, 1, 2, as opposed to looking at one of the 6 different possible ways of writing those 3 numbers. Right? You can write them in 6 different orders, which you'll learn in 30-day. And then the range is what? Definition. Sorry, before we put the numbers down, what's the definition of the range? All the y values, right? Okay, so I'm going to look for the lowest y value, which looks like -1. Looks like it goes as -1, 2, 5, 8. -1, 2, 5, 8. So we were finding domain range of set ordered pairs. Yes.
In domain, how come you only put 3 down? How come you put 4 down?
We don't repeat. So then that leads to a problem, right? So the problem is, if I gave you the domain and the range, could you regenerate this? So if you didn't know this, and I gave you these, could you write out the set of ordered pairs? No. Right? There's no way. You don't know. They don't match. And even if they did match, it doesn't mean the first one goes with the first one, right? It just means that one of these goes with another one of these, I don't know which, and there's no way I can write out for you. So that's the problem with doing domain and range, is we lose some information, right? Like we don't know, if all I see is this, I know the possible x values and y values, I don't know how to put them together to make this. Okay, y equals x squared plus 2x minus 8. So we do that? I think we did that one, right? Yeah, we did that. Okay, so what values of x can you put in there? Are there any values of x you can't put in there? Is there a number that I can't square? I can square 0. 0 times 0 is 0. So is there any number you can't square and then add to 2 times that number and then subtract 8 from? Yeah. So when do you get restriction? If you have a square root sign, what can't we take the square root of? What kinds of numbers? Negatives. Can't do square roots of negatives, right? But we can take any number and we can square it and we can multiply it by 2 and we can subtract 8 from it. So we will say x belongs to the reals, right? Or is an element of. That's what that kind of curvy E says. Belongs to or is an element of the real numbers. Okay, what about the range? So what does this thing do? Kind of bottoms out, right? It's got a low value, but then what do these arrows say? Keep going. So how low can you go? -9. So then what's the range? If you can go as low as -9, then the y values have to be what? And infinity. So what's a fancy way to say that? I feel the same way. Y is greater than or equal to -9, right? So if a quadratic opens up, it has a minimum or a low value, which means all the y values have to be bigger than or equal to that value, which is at the vertex, which is where the axis of symmetry goes through. We're going to do a whole pile of that stuff coming up. Domain. Where do my x values go from? From where to where? Between what? Between -1 and +7, right? That's where the x values go. So we write that. So you always do it as the low value is less than or equal to x, which is less than or equal to the high value. Always, always, always. Only one way to write this. This is the one way. The only way you write it. Okay, so the low value, I'm going from -1, it's just going left to right. It's how we read, it's how we write. Okay? -1 is less than or equal to x is less than or equal to 7. All that says is my x values are between -1 and 7. What about my y values? So my y values are between -3 and 5. So when you're writing, I hesitate to use the word range, but it is a range of numbers, right? Even though, so the range of the range is between -3 and 5, right? You go the low value is less than or equal to the variable, which is less than or equal to the high value. Okay? We can't reverse this. If you reverse it, it's wrong. If you reverse it, you actually end up with numbers going down here and up there. So you can't, right? So you have to say it's between here and here. Okay, questions, concerns? Which of the relations above are functions? Okay, what makes a relation a function? What's the definition of a function? Yeah. Right. What'd she say? What'd she say? What'd you say?
Oh, no, that's right.
Well, give it a shot.
Big cats have the same range.
That's kind of there. Can't have the same domain. So every element of the domain, every x value has only one y value associated with it. So this, not a function, because 2 gives you a 5 and 2 gives you a -1, right? So every element of the domain, that 2 can only have one y value. In this case, it has 2, so that's not a function. This one is a function, and this one, is that a function? No, because if I put in a 3 for x, I can get 5 and I can get -3. Okay, so which of the above relations are functions? B is a function. So only the parabola Using function notation. If f of x is equal to x squared plus 2x minus, wait a sec, I think I've gone too far. Or did we go just far enough? What are we doing? A to f, far enough. Okay, we overstepped. I'm worried about finishing. Okay, so now what you want to do, that's not what you want to do, the least thing in the world you want to do is you want to do A to f on the following page, right? However, you should do it. It's in your best interest. Because you're going to make a good first impression on me, it can't be, and then when we're done, I just sat around and talked. Right? So make a good first impression, which is, do some work. Okay. You have about 5 minutes though, I know you're tired of that, so sit quietly, talk amongst yourselves. Tonight, look at A to F. Well, do A to F. And then by tomorrow, I'll have the answers for that posted on the Schoology site, and I'll have stuff set up and that. So